this video, this is a short video, we're going to calculate the standard deviation of the data in those really, really big data files, 10 meg and 1 meg data files. And this program is going to be pretty similar to the average underscore big program, so let's start with that one. We go to Finder, and we find the folder average underscore big, and we make a copy of it. And then we change the name to stdev underscore big. We go into that folder, and then we erase the executable, and we change the name of average underscore big.c to stdev underscore big.c. When we double click on it, it comes up in Xcode, and then we're ready to start. We have to, because we're doing math here, the power and square root, we have to include the math.h. So you go up to the top and do hashtag include math.h. And then we also need to include the variable for the sample standard deviation, s. And it's got to be a double because we're doing doubles, not floats, because this is a really big data file that we're going to be calculating. So we do double s. And those are the big changes that we make at the top. We're going to calculate the average the same. You can see that part is not going to change at all. And we get the average from that loop, the while loop. We also get the number of points. In the standard deviation program that we did before this, we used a sub I. We had to reuse a sub I because we used it to calculate the average, and then we had to reuse it below, after we calculated average, to calculate the sum of the squared differences because average was in that equation. What do we do now? We don't have a sub I. We don't have a 10 million point array that we've stored. We used temp instead. That's the trick of this program, of this video. The trick that I'm trying to teach for this particular program is that we have big data files. Sometimes just using the data file itself as the source of your data is fine. So every time you need to access it, you just reopen the data file and reread the data. So there are a lot of issues about access time and all that stuff, and so there's all sorts of issues related to that involve programming. But this, for a beginner, this is a really kind of neat trick. It's just to use the data file itself as the source of where you're getting your data. So I've closed the data file from the first loop there when I calculate the average. So all you have to do is just reopen it. fp equals fopen, the same line it's exactly. And then now, instead of a while loop, we can do a for loop because we know how many points there are. So I say sum equals 0, and then for I equals 0, I less than n, I plus plus. And in there, I do the fscanf statement for temp. And then below that, I say sum equals sum plus, and then pow, temp minus average to the second power. Once I'm done with that loop, then I can do close again as a housekeeping measure, and then I calculate the sample standard deviation, s equals the square root of sum over n minus 1. I add a printf statement to print that out, and I'm ready to go. And so we do command s, we save that. And then I go into my terminal, I double click on the terminal icon, cd desktop, cd C code, cd std underscore big, stdev underscore big. And then I compile the file, and then I'm going to run it. I run it with the O10, and I got the exact same answer as it did with the other stdev program we did. And then I did O1 million and O10 million, those two data files. And you can see the answer there. I can't really verify if that's the right answer or not because those files are too big to use with off-the-shelf technology, but I know that those standard deviations are about right. I generated all of these files with a random number generator, and so the standard deviation is going to be about the same for all of them. You can see that it's about the same, and that makes sense. So that all jibes with what I expect as a result. So that's the quick little trick that we learned. Sometimes with big data, all you got to do if you want to re-access that data is just reopen the data file and just keep using temp.